In lesson 7.2, we are going to be talking about similarity and transformations. And I'll remind you that we did talk about transformations in first semester at the beginning of chapter 4. We had discussed the translation, the rotation, and the reflection, that of which many of you are familiar with from your middle school geometry units. And we added one more called the dilation. Now, the translation was our slide, the rotation was our turn, the reflection was our flip, and then we discovered that when we had a dilation, we were actually enlarging or reducing our figure, sometimes also called a stretch or a shrink. Well, as we look down below, we can kind of classify these transformations, and some of them are going to be considered congruence transformations. So a congruence transformation is a transformation that preserves the length, angle measure, and area of your figure. So the pre-image and the image, my figures will have the same length, angle measures, and area. Image and pre-image are congruent. Those may also be called an isometry or a rigid transformation. Those are some other names that are used. So if I ask you to think about our 4 transformations and what would result to be a congruence transformation? Well, hopefully you would agree that a translation would result in congruent images. A rotation would result in congruent images and a reflection. In all of those, our figures, our pre-image and our image are the same shape and the same size. Now, a similarity transformation is a transformation that produces similar figures. I'll remind you that that means that we have congruent angle measures and side lengths that are proportional. So here my image is similar to my pre-image. And knowing that our dilation results in an enlargement or a reduction, that is going to be a similarity transformation. Okay, so on the back of your note sheet, I put at the top just a little reminder. This chart we have actually seen before in chapter 4, and it kind of explains how our translation rules or our transformation rules are written. The translation rule, we see the reflection happens when we add in that one negative sign. The rotation happens when we're either switching our x and our y and adding in our negative. And then finally the dilation rule written in the form xy mapping to kx and ky, where we're going to refer to k as our scale factor. Okay. Now today we're going to investigate what happens with different scale factors. So if you look down below at example A, it asks us to apply the dilation D to the polygon, to name the coordinates, identify and describe our transformation. So our transformation rule says to take xy and map it to 1.5x and 1.5y. This means we are going to take our x coordinate and we're going to multiply by 1.5, and then take our y coordinate and also multiply by 1.5. So let's first start by finding our new coordinates. Let's find L prime, M prime, and N prime. Now if I take negative 6 and I multiply by 1.5, I get negative 9. If I take 2 and I multiply by 1.5, I get negative 3. And we're going to do that for each coordinate. I've named my new coordinates. Now I'm going to come come over here and I'm going to go ahead and graph them or plot my points. How are we going to identify and describe our transformation? Well, we know that when written like this, we have a dilation. And I might mention that my scale factor is 1.5. What happened to our triangle? Well, we can clearly see that we had an enlargement. And so as I describe this, I'm also going to say it was an enlargement. Okay, well, let's take a look at the second one. The second one asks me to take xy and map it to negative 1.5x and negative 1.5y. So we're going to investigate what happens. We have a similar scale factor, but this time we have a negative thrown in there. So let's start by finding our new coordinates. Multiplying each by negative 1.5. Now I'm going to go ahead and plot those points and graph my triangle. Okay, what happened here? Well, it clearly got bigger, but we can also see that the negative caused it to rotate, right? If I have my scale factor negative 1.5 and negative 1.5, the 1.5 caused my triangle to enlarge, but the two negative signs, if you look up here at the top, negative, negative, actually causes a rotation of 180 degrees. And that's what happens in that second example. So sometimes kids think because this is a number that's smaller than 0, they think that it's going to get, my triangle is going to get smaller. But the number, the 1.5 causes it to enlarge. The negatives actually cause it to rotate. So what happens here? Well, actually, it's kind of like a compound. It's a dilation and it's a rotation. You could, it's a rotation, I'm going to say of 180 degrees, but my dilation is an enlargement. Okay, so the question is, how do we know if our figure is going to be larger or smaller if we have a dilation? Well, let's make a note at the top. If we had talked some about this in semester 1, when we have a figure that enlarges, our scale factor is going to be either a number that is greater than 1 or ends up being a number that's less than negative 1, if you want to think about it that way. Because here our negative 1.5 would fall into that category. When does our figure reduce or get smaller? Well, that would be when we would have our scale factor as a fraction or a decimal. Agreed? If we had 1/2 x or 1/2 y, or 0.6x and 0.6y. So we actually can say that we reduce if our scale factor is between negative 1 and 1. But, of course, we cannot have a scale factor of 0. Now, what would happen then if we had a scale factor of negative 1/2? Well, our triangle here would have reduced, but it also would have rotated because of the negative signs. All right, so let's take a look at example B. It asks us to write a transformation rule that will result in an image that is congruent to the pre-image. Well, if I need my image to be congruent to the pre-image, I need to think about a congruence transformation, correct? We could write a rule that was a translation, a rotation, or a reflection. But this is not a rule. So I want to actually give a specific example. Let's say we want to write a translation rule. Well, we're going to write it in arrow notation, just like above. Maybe I'm going to say, take x, y, and map it to the point x minus 1 and y plus 3. We know that would result in a slide, a translation, right? We would go left 1 unit and up 3 units. That would be one example. Or maybe you want to run an example of a reflection. If I wanted to do a reflection example, I could say take x, y, and map it to the point negative x, comma, y. This would result in a reflection over the y-axis. So there are many different answers that would work for this. In fact, everybody could have something a little bit different. But we want to make sure that it would fall into one of those 3 categories. Question 2 asks us to write a transformation rule that will result in an image that is similar but not congruent to the pre-image. So similar but not congruent, we know that we want to look at a dilation. And we do not want our scale factor to be 0. We also do not want our scale factor to be 1. So if we are going to give a specific example, it does not tell me if it has to be larger or smaller. So I'm just going to go ahead and write, take x, y, and map it to the point 1/3 x, comma, 1/3 y. And that would be my final answer. Now, what's going to happen here when I have 1/3 x and 1/3 y? Well, this would actually give me a reduction, right? That would make my figure to be smaller. And if I happen to put in my negative signs, well, then it would be a reduction and it would be a rotation of 180 degrees. Okay, if you have further questions on this, please stop in and